This is a steam generator just sitting on a bench, hooked up manually. I've got switches on the power and switches on the water supply. So I just wanted to demonstrate what it looks like without the insulation. Of course, steam goes out the pipe on top, the radiator hose cut down, and that white PCP hooks right into the ducting, the return duct actually. So it's running at a fairly low power right now. It's about 6 amps. One on the left, the one on the right is about 10 volts. That's the voltage that's on the high point sensor. So when the electrolyte gets up to the high point sensor, that voltage will come way up. And as the water goes down, I add water. And it cools it momentarily, but it starts back up pretty quickly. And of course, when it's insulated, it doesn't even stop boiling when we add water. It just continues to boil. So we're losing quite a lot of heat in this situation. So it's coming back now. It's starting to produce steam. It's running back about up to 6 amps. And the computer, as well as controlling the water supply, it also controls the power to the electrodes. Turns it off when it's not needed. And back on again when it is needed. One more time. Off, on. So I'm going to be adding more water and increasing the level to show the high point sensor reaction. It's still not really touching it very much. Even when it's boiling, it only touches it a little bit. Okay, now the level has reached the point where it's splashing up on the electrode enough now so that it's going to be averaging somewhere around 80 to 90 volts. So this is the point where the computer would say no more water. So as the steam generator operates, it continues to increase the salinity, the conductivity of the solution, and it draws more and more current. The computer's monitoring this, and when the level reaches the maximum ability of the machine, which in my case is about 15 amps, it calls for a purge, which will purge about 2 cups out of the steam generator and replace that with plain water. So that will in effect dilute the solution. So how this works is we just add water until it reaches the point where it starts to drain. At that point, we could stop adding water and just let it sit and watch it. So this will continue to drain until it gets down below the purge pipe outlet. And as we operate and continue to add water, it will dilute the solution and lower the voltage, or rather lower the current back down to a more reasonable value. So the purge is almost complete. It will stop right about now.